Light, regarded as the fastest entity in the universe, travels at a speed of 300,000 kilometers per second. This speed is unimaginable in our daily lives. The renowned physicist Albert Einstein concluded that nothing can travel faster than light. However, even this fastest entity becomes incredibly slow in the vastness of space. Today, we'll introduce just how slow light is in the vast universe. The speed of light is 300,000 kilometers per second. In 1 second, it can circle the Earth 7.5 times an unfathomable speed. Until the 1600s, this extraordinary speed was thought to transmit instantaneously. Measuring the speed of light requires knowing the distance traveled and the time it took. But since light can circle the Earth in a fraction of a second, how was its speed measured? In the 19th century, French physicist Armand Fizeau successfully measured the speed of light for the first time. Fizeau placed a toothed wheel near the light source, ensuring that the light passed between the teeth. He then placed a mirror 8 kilometers away. The wheel could rotate. When the wheel turned slowly, the returning light passed through the same gap between the teeth. But as the wheel's speed increased, the returning light was blocked by the teeth and became invisible. By calculating the rotation speed at the moment the light was blocked, Fizeau deduced the speed of light. His experiment estimated it at 310,000 kilometers per second. Today, we know the precise speed of light is 299,800 kilometers per second. Fizeau's experiment, conducted nearly 200 years ago, had an error margin within 5%. It's astonishing to think such a sophisticated experiment was conducted in the era of early gasoline-powered vehicles. While this precision is required to measure light's speed on Earth, light can feel slow on the vast scale of the universe. Let's experience the slowness of light. In this visualization, light is shown circling Earth. It's breathtakingly fast, isn't it? Now, let's see how light travels from Earth to the Moon. The light's journey between Earth and the Moon resembles a game of catch. Compared to its speed around Earth, it feels slightly slower. The distance between Earth and the Moon is about 380,000 kilometers. And it takes light about 1.3 seconds to cover this distance. Thus, the Moon we see from Earth is always 1.3 seconds in the past. Next, observe how light travels from Earth to Mars. The white light moves slowly, doesn't it? This is the speed of light traveling from Earth to Mars. Compared to its journey to the Moon, it feels significantly slower. Even so, this is still the speed of light. The distance between Earth and Mars varies, and at its farthest, it takes about 24 minutes for light to travel between them. In the vastness of space, even light appears to move sluggishly. So, why is the slowness of light a problem in space? Let's consider the Voyager 1 spacecraft, the farthest spacecraft from Earth. Voyager 1 was launched in September 1977 as an unmanned spacecraft. Its initial mission was to explore Jupiter, but it far exceeded expectations. By 1980, it reached Saturn and captured stunning images of its rings. It's incredible to think such beautiful images of Saturn were taken so long ago. Even more astonishingly, after departing Saturn, Voyager 1 exited the solar system and took a family portrait of the solar system, comprising 60 consecutive images. This photo, known as the solar system family portrait, makes us realize Earth's place within the solar system. Voyager 1 continues to demonstrate the vastness of space as the first spacecraft to exit the heliosphere. However, light's slowness complicates Voyager's mission. Currently, Voyager 1 is flying approximately 24 billion kilometers from Earth. At this distance, communicating with Voyager takes 2 days. Why does it take 2 days? Communication with spacecraft uses radio waves, similar to smartphones. Radio waves are a type of electromagnetic wave, traveling at the speed of light 300,000 kilometers per second. While nearly instantaneous communication occurs between Earth and satellites, with Voyager 1, it takes 22 hours for a one-way signal, and 44 hours round trip. Communicating with Voyager feels akin to exchanging letters. Though light is extraordinarily fast, the vastness of the universe makes communication time-consuming. In space, light can be considered slow, but light's slowness isn't always disadvantageous. How does this benefit us? Let's consider observing distant stars. For instance, Proxima Centauri, the closest star to the solar system, is approximately 4.2 light-years away. A light-year measures distance. It's the distance light travels in 1 year. About 9.46 trillion kilometers. It takes 4.2 years for light from Proxima Centauri to reach Earth. Thus, we're seeing the star's light from 4.2 years ago its past appearance. For even more distant stars, light from them takes tens of thousands to millions of years to reach us. A famous example is the Hubble Ultra Deep Field, captured by the Hubble Space Telescope. This photograph reveals galaxies more than 10 billion light-years away. These galaxies' light, originating over 10 billion years ago, offers insight into how early galaxies evolved after the universe's formation. Thanks to light's slowness, observing a galaxy 100,000 light-years away reveals the universe as it was 100,000 years ago. Observing a galaxy 100 million light-years away shows its state 100 million years ago. It's like traveling back in time, a remarkable phenomenon allowing us to view the universe's past in real time. Can we eventually see all distant galaxies, even if we wait billions of years? Unfortunately, no. The vast universe is expanding. Our universe began about 13.8 billion years ago with the Big Bang. Since then, it has continuously expanded. How do we know the universe is expanding? This discovery was made by Edwin Hubble, the astronomer, after whom the Hubble Space Telescope is named. Hubble observed that the farther a galaxy is, the more its light shifts toward red wavelengths, a phenomenon known as redshift. This occurs because light's waves stretch as galaxies move away, making them appear redder. Thus, Hubble revealed the universe's expansion. For instance, if a galaxy is 1 meter away and space doubles, the distance becomes 2 meters. Similarly, a galaxy 10 meters away would move to 20 meters. Farther galaxies recede faster due to this proportional expansion. Eventually, galaxies move away faster than the speed of light. Light emitted from these galaxies can never reach Earth, as the universe's expansion outpaces it. Consequently, the number of observable galaxies decreases over time, making the current night sky feel all the more precious. Today, we explored the slowness of light. While its slowness complicates communication with distant spacecraft, it allows us to observe the universe's past, spanning over 10 billion years. Light's speed is both a limitation and a gift in understanding the cosmos. Don't forget to like, comment, and subscribe for more videos about space and science.